Hello and welcome back. We have left off in exercises generics 1. And as you can see, expected identifier, we just have to fill something out over here. So as you can see, this shopping list program isn't compiling. Use your knowledge of generics to fix it. So before I will dive into the exercise, I just want to make a little bit more clear what a generic actually is. So as you can see here, we are in the main function. We have here a variable number list and it holds a vector of integers. And then it will pass a reference over here of this vector. As you can see here, we have a reference of number list. Then we have char list, which is a vector of chars or characters. And then this will also get past a reference to the function largest. Now, how is it possible that we can first pass a vector with integer types and then passing a vector with char types? And you could basically write two functions. For each one you can write, for example, largest in number list and then find basically what is the largest for that, and you write another function for that, but that would mean a lot of duplication in your code. So what we actually do in this case is we use generics. As you can see, it's basically a normal function, but after the function name you declare a generic. So this happens between the function name and the list of parameters. And you basically give your generic a name, and mostly you use T, you use simple short names. And as you can see, the argument list expects a reference of an array, or in this case a vector of type T, and that's the generic over there, and it returns a reference to T. So what this function basically does is it will just find the largest item in the list. So for example, over here, the largest one would be 100. So this will then return a value of 100. And that's, of course, an integer type. So here, what will get passed is a vector of integer types, or to be more precise, i32 bits. And then this will hold a reference to a vector of i32 types. So basically our generic in this function call will be i32, and then it will return a reference to an i32 value. But in the next function call over here, our generic will be of type char, because we are passing chars here and not integers anymore. So we expect here a reference to a vector of char types. Our generic will be a char type, and we just return a reference to a char type. So I think it will be more clear if you also just look at what I do in the exercises, so you will get the feel out of it. So use your knowledge of generics to fix it. So here we have a variable which is mutable shopping list, and it holds an empty vector, and then we push it a string slice. This is a string slice, so we pass that into the vector. So we basically have to define the type of the vector elements over here, but I will give you it's like a cheat code, in the old games when you had these tricks, you don't even have to define a type. It just works because Rust compiler will here basically just fill out this information. So here it's an empty vector, and then a string will get pushed. So it will hold string slice type. But of course, we will do the exercise. So what we can fill out in here is just string slice. Why? Because we only have one element, and it's basically clear that this vector holds a string slice. Like that. So that one was easy. This powerful wrapper provides the ability to store a positive integer value. We write it using generics so that it supports wrapping any type. So as you can see, we have a struct wrapper here which holds a value of type unsigned integer 32 bits. And over here we have a method implemented for wrapper which is called new, and it expects a value of type unsigned 32 bits. So this argument over here expects this type, and what it basically just does is it basically makes an instance of this wrapper over here and fills out this value with the value over here. And this is basically a shorthand. You could also write it like that, but as you can see, it's even by the way, I have now installed that one, so we should actually see all the types basically. And as you can see, shorthand struct initialization, we can basically just do it like that, or as you saw, like this, but this is basically not necessary, because what we mean over here is we pass it the value of this argument, but of course it has to be the same name so that you can use this shorthand. Now over here you can see we have the tests. Let me zoom out a little bit. Right, so we basically make a new wrapper. We call the new method with an integer, and then it should basically, the value of it should basically be equal 42. And if we pass to the method new a string slice, it should be basically value. This should hold then a string slice. So we can use generic types in structs, and it's basically the same as in the function you saw. Use it like that. Now we have our generic type over here. Basically, we can then define that value should hold t, and over here syntax is like that you basically have to implement it like that. You have here the generic, and this is basically the declaration, and then you will use it over here. This has to be the same type, and we can then here use t like we did over here. When you declare a generic type, you can then use it. All right, let's see. It's compiling. So what we accomplished here is that we can pass the method of the struct wrapper any value, and then it will get initiated with this value. So here we pass it an integer, and then what we basically have is over here 42, because we pass it here 42, then it will get filled out in the value member of the struct, and then it gets stored basically over here. So we have 42. Now we can also pass string slices. So here we pass it foo, and then it again gets assigned to this value over here, and this will hold foo like that. And we can basically pass it anything. Right, I think that's all about generics. Right, and the next topic will be traits. See you then.